Welcome everyone to the August 2021 edition of UDC. And today I'm very excited because we're here to be talking about writing better components with state machines. So we got to introduction for Reinier in just a bit. But as far as the usual, if you're new here, welcome. So here are the organizers for UDC. I guess I'll start with introducing myself. I'm Ben Hong, and you might have seen my work a bit on the docs as well as on the Vue core team, and do a bit with Netlify as well as Nux. So y'all have any questions, don't hesitate to reach out. But I'll hand it over to Tracy next.
Yeah, so I'm Tracy Olenka. I work at Bloomberg and news engineering.
Perfect. And then our other two organizers, Chris and Jack, could not make it tonight, but Chris Guerreri is at Politico as a lead front-end developer, and Jack as well working at Compass. And so, yeah, we're happy to support you all and keep throwing these events. As far as UDC updates, we're up to 1,055 members. So nice to see us hovering consistently above the 1,000 mark. It's been pretty great. And yeah, it's crazy to think that our first meetup was back in December 6th, 2017. I don't know about you. Can you think about that? Feels like so long ago.
Yep. It was before the first Vue conference, right?
Yeah. And not to like pre-COVID times. Gosh.
Yeah.
It feels like ages ago.
It does.
And
yep.
You know, so while I know some places have started doing in-person events, we're going to continue to do these remotely just because, especially with the Delta variant, we just want to make sure that everyone can stay safe. And so for now, we're just going to keep hosting them. They're usually on the third Wednesday of each month. And so, yeah. With that, as far as upcoming events and meetups, we have so many actually events coming up the rest of the year that I didn't even have time to fit or space to really fit the meetups. But just so you know, there are a lot of conferences coming up for the rest of the year, and all of them actually remote. Some of them I think have an in-person element if you do want to attend. So I think Vue Global is one example of this. But if you are a Nuxt fan or want to learn more, Nuxt Nation, so the first dedicated conference to Nuxt is on September 15th, 2021, and that'll be coming along, less than a month. But then there's Vue Global. You're probably more familiar with the brand as Vue.js Amsterdam, and that'll be on October 1st. And so you can sign up. Again, we'll include the links in the Vue DC Discord so y'all can check it out. And just know that Vue London is also happening later that month. And then we have Vue Toronto at the end of November. So lots and lots of Vue content coming your way. And if we can, we'll be doing recaps of those things as time goes on. So that said, as always, if you need support, the VueDC community is here for you. So basically bookmark our website at vuedc.io, and you'll see in there that there are invites for like the Discord channel, as well as like, links for our meetup group. And basically the Discord channel is basically a subset of like the VueLand channel that you might know for like the primary Vue. And so I know sometimes it can be a little bit noisy and hard to get sort of like attention in that particular channel. So, if you join our community, usually you can get a little bit more of a personalized experience there. And so I try my best to hang out in there, and happy to help as y'all need it. All right. And finally, we are always looking for talks. So if you have any desire to speak, whether it's a lightning talk, full talk, whatnot, or need help picking a topic, don't hesitate to reach out to us, and we're happy to support you however we can. With that, I think since Jack is not here today, and so for this, I don't think we're going to be doing trivia for this particular round. But Tracy, do you have anything else before we get started with our talk for today?
No, not really.
All right. No
I've
worries.
been like, I'm sort of on vacation for the last 2 months, so I'm just like getting back into it. So yeah.
Yeah. Well, with that, I'm really excited to present Reinier Kaper here, who will be talking to us about stateful machines with components. I'm very, very excited for this. So with that, take it away.
All right. Thanks, Ben. Well, first of all, thanks for letting me do this. I'm sure it will be fun and hopefully a bit of a learning experience. Let me start off by sharing my screen, which might not be a bad idea. And let me know if this is all visible. Hope we're good.
Yeah, we could see it.
Okay, perfect. All right. So writing better components with state machines. That's what I'm going to be talking about. And I'm going to divide this talk into two pieces, basically. First, I'll do a little bit of introduction about myself and what state machines are. And then the second part, which is, in my opinion, the more interesting part, is I'll be live coding an example component in two ways. First, I'll do something in sort of more traditional way. And then the second part will see how state machines can hopefully improve the component a little bit and reason about writing components. So that's I always like that part, and it's live coding, so stuff will go wrong, but that's all good. All right, so a little bit about me. I'll try to keep this short. My name is Reinier. I work as the lead front-end developer at Creative Layer. I was born and raised in the Netherlands. I lived there for 30 years, and then my wife and I moved to Canada in 2011, and we now live in Ottawa and have a beautiful little daughter, and we have no plans on turning back. So we're here to stay. I lead a small group of front-end developers at Creative Layer. We're the four of us, and we all work remotely. And what we do a couple of things. The main thing we build is a workflow app that hooks into Shopify and helps smaller businesses that do anything with print. Say like they make caricatures of people and print them on canvas or on normal paper or whatever. We hook into Shopify, take the orders, and guide them through the whole design process flow and fulfillment flow, because that's sort of our background. We were split off from a different company called Canvas Pop. Look it up if you're interested. They do home decor prints on canvas. And that's sort of where we came from. And our sort of long-term goal is to provide a platform where people can generate their own art and then hopefully offer that in different storefronts like Shopify or Etsy or stuff like that. We also build a couple of libraries, like component libraries, and everything is view-based, obviously, otherwise I probably wouldn't be here. We write everything in Vue 3, and my talk will also use Vue 3. If you're not familiar with Vue 3 yet and you still use Vue 2, that's not a big deal because there's not a lot of Vue 3-ish stuff going on. And the little things that are Vue 3 specific are probably not too hard to grasp, and it's more about the concept of state machines. Sorry, the concept of state machines anyway, so I think we'll be fine. You can find me on pretty much only on Discord and Twitter and GitHub under the Dutch Coder. I'm fairly active on Discord, trying to help people out and sort of contribute to the community. If you have any questions about my talk or anything else, hit me up there. I'm always willing to help. So that's me. Let's talk about the actual goal of the talk. So there's two things I want to hopefully achieve today. And the first thing is making people familiar with the concept of state machines. What they are, what they do, and how they work. And then the second part, hopefully, is getting you excited about it, because for me personally, state machines were one of those sort of epiphany moments. Remember when we used to write CSS by hand, and then things like Less and Sass came along, and you're like, your mind was sort of blown. You're like, why aren't we doing this all the time? And so that's sort of how I feel about state machines as well. So hopefully that rubs off a little bit, and you will be excited about it as well. That's at least my goal. So let's go for it. So first, a little bit of the sort of the dry theory. What are state machines? State machines, they're technically called finite state machines, and they're actually mathematical models. So they've been around for quite a long time, and that's also one of the key factors that makes me wonder why we're not using this all the time, because it's a sort of a tried and tested model already. And state machines describe behavior of a system that can only at any given time be in one specific state. And formally, there are 5 parts to state machines: a finite number of states, a finite number of events that make states transition, an initial state, in other words, where does the machine start, a transition function that actually deals with moving from one state to the next, and then a set of one or more final states, and that basically describes when the machine has done its work. And I always like to illustrate it with a super basic example. So most homes in North America, or maybe even other parts of the world, come with some sort of climate control, right? So during the winter, we turn on the heat. During the summer, we have AC that cools the house. And then obviously your thermostat can also say, like, let's not do anything. Let's be in the off state. So that's usually, let's say that's the default state for any sort of climate control. You have the cooling state and then the heating state. So basically we have three different states, and the thermostat can only ever be in one of these states, right? You can't be in cooling and heating at the same time. Probably technically you could. It's a pretty poor idea, I guess, but let's, for the sake of it, say that you can only be in one of these states. So when we're in the off state and we send a cool event to the thermostat, the AC kicks in. If we're in the cooling state and a heat event is triggered in that thermostat, we go to the heating state, and then we can go to an off state again by sending an off event. Obviously, in most, especially more modern thermostats, you can have transitions between all of these states. So from heating to cooling, from cooling to heating, etc. This is just to illustrate like how a state machine in theory works. So that's really the basic example of a state machine. Now there's another concept called state charts, which basically builds on the fairly basic definitions of state machines. And state charts were introduced by computer scientist David Harrell in '87. So it's been around for a long time. So why not make use of it? And some parts that state charts do on top of state machines are guarded transitions. And guarded transitions are, for example, before moving from one state to the other, you can check if certain parameters are true. You can do that in the event that's being sent. You can check some data in there, or you can check against other pieces of the state machine. There's a thing called actions. And actions basically let you do things after you transition from one state to another. So for example, if you fetch data and your data fetching is done, you probably want to do something with the data you get back, and that is handled in an action. Then there's some other cool stuff. You can have parallel states. So even though a machine can always be only in one state at any given time, you can have parallel states. And a good example for this is, for example, if you have a form, like a login form with an email input and a password input, the state of the form itself could be in the input or idle state, but the email field and the password field could each be in their own state. For example, the email field could have an error, whereas the password field could just be in a normal state. You're still within the encapsulation of the idle state of the machine, but the substates can be in their own different states, so to speak. So that's parallel states. And a nested states is part of that, where I just said like the form itself could be in an idle state, but your different inputs could be in substates of that. So that's a nested state. So more practically speaking, how can we leverage the idea of state machines into our components, or just JavaScript in general? In JavaScript, we have a fairly extensive library. It's called XState, and it's built by David Khorshid. Fantastic guy, and ditto library. It's incredibly well done. And it basically allows us to use the concept of state machines and state charts within JavaScript. And it's framework agnostic, so you can use it in any framework if you like. But there are different plugins available for, I believe, for React, maybe even Svelte or whatever. But definitely there's one for Vue as well. And the Vue library, or the Vue plugin, I should say, really is just a composition function that gives you sort of like tools back from the interpreter of the state machine. And to give you an example of a good state machine within JavaScript itself is if you look at promises, which we all pretty much use on a daily basis probably. A promise itself is a great illustration of a state machine, because a promise could be in an idle state. It hasn't actually triggered yet, right? You could argue that it's not a real state, but for the sake of argument, let's say it is. Then a promise could be in the resolving state or in the loading state. It's fired off its a request, but it hasn't received any data yet. And then there's basically two outcomes after that. It could be resolved or it could be rejected. And that's a perfect example of a state machine, because it's very predictable. We all know like a promise will either succeed or it won't. And it will never be both of them. You also know when it's still loading, you can await that. So it becomes a very predictable system. So that's a great illustration of a state machine in JavaScript itself. Now, with the XState library, we get a couple of basically helper functions or tools that will help us in writing this logic in our components. So specifically the view package, the XState view package, they give us three things back when you define a state machine. You get something called back the state, you get back a send function and a service. And quickly speaking, the state is literally the state that the machine is in at this time. It's a big object with all kinds of parameters and data you can read, but it's a literal representation of the state the current machine is in. So you can check against all kinds of stuff there. Then there's a send function, and the send function is really nothing more than a function that sends off an event to the state machine. So if you're in state 1 and you send an event and state 1 is configured to do something with that event, then that's what you use a send function for. So it's very helpful in communicating between the component and the state machine, as we'll see later. And then the third part that you get back is a service. And the service basically handles the transactions between the states. And you can also listen to, for example, when the service ends, when your machine's in its final state, to do something. So that would be, like, to give a quick example, a good example would be if you have an auth machine where you log in and you check credentials and that kind of stuff. At some point, you will be fully logged in and the machine has done its work. It will reach the final state. And then you can listen to that in your component and send the user off to /profile or wherever you want to go, right, with the router or something like that. So that's a good example of that. So that's really, in a nutshell, what state machines are. And I just told you there's a package available to use it. And in my experience, the best way to actually get familiar with it is just doing it, just writing something and see how we can leverage state machines and hopefully make our lives a little bit easier. So I will move over to actually writing. Oh no, my desktop is now gone. Of course this happens. Here we go. Okay, I hope you can see this. Let me know if you can't and if it's readable. That's important.
No, I can see it, and I think it's readable. And I'm pretty blind, so we're good.
Okay.
I think, yeah, bumping it up right there. I think this is probably more ideal. Yep, this is good.
Okay, perfect. Okay, so I'm just gonna take an easy example, write a component that I think a lot of people are familiar with in some sort of way. It's going to be very basic. And what this component is going to do is it's just going to fetch a list of users and display it. Well, it couldn't be easier, right? But I'm sort of going to progressively walk through it and add some functionality to it, and then we'll hopefully see at some point where it kind of gets a bit muddy and why state machines can help us. So on the right here, I have, sorry, I'm now glancing at my code. I have to write this, obviously. There's a hot reloading server running, and on the left here is my code. If I change anything, it should update. Well, that's good. So let's start off by writing a very simple component that sort of fetches data. And for that, I'm just going to mock out a quick API, like a mock API, so that we can just fetch data and do something with it. So let's return the new promise here that either resolves or rejects. Oh. And let's say, just for now, let's give it a timeout so that's actually async. And let's give it a timeout of a second. Don't want to keep you waiting too long. And for now, let's resolve some data. And the data is going to just be a list of users. So this obviously will normally be something like a regular API call, right, in your system, but let's just mock it out for convenience sake. Okay, so this will give us some data back once we call it. And now we're going to actually write a bit of code in our component. So again, this is all in Vue 3. If you're not familiar with Vue 3, the setup function might seem a little bit strange, and things like refs are odd, but it's simply just a replacement for how you normally would use your data and then your methods and your computers and stuff like that. So hopefully you can follow along. I'll explain what I do when I go. So when this component loads, we obviously don't have any data yet. So let's store our user somewhere, and let's say that's an empty array by default. And then we obviously will return this to the template so that we can use it and loop through it in a second. And the first thing we want to do is we actually want to fetch our users, right? Because otherwise we don't have any data to work with. So let's do that. And let's call our API, and we'll get to the try catch in a bit. So we call our API, we get our result back, and then we set our users to be that result. And then hopefully we're able to loop through that in our template. So in here, let's say, well, if we have some users to work with, let's render this this whole list. So we don't need this. So I do v4 equals user. Ooh, sorry. Let's key this properly. And then we have the username here. Didn't get anything. I forgot to actually fetch the data. So let's do that right now. Fetch the users for me. There we go. Okay. So in a nutshell, what happens is once the component mounts, we call fetch users, which actually calls our fake API over here. That resolves after 1 second with some data. We store that data on our user's value here, and then we loop through it. So it's pretty basic, right? So that's basically how we fetch data in an old way, but that's too bad. Like we don't really think this is a useful component yet, because while the data is loading, we obviously want to show some sort of loading state. So let's add that in and keep building our way. So we probably want to keep track of a variable that tracks if we're loading or not. So by default, we're not loading anything yet. So let's set that to false. And then once we start fetching users, let's set that to true so we know we're loading data. Then we're also going to actually properly try to catch some stuff here. And add a finally in here. Okay, so we'll try to grab our data. If it goes wrong, oh, we have to do something here. Well, we'll get back to that in a second. And when we're all done, our loading is now set to false. We return that. And let's add a message here that shows up while we're loading so that the user knows that we're doing stuff. Wow, well, that worked. Good. Okay, so now our users are aware that we're loading data, and a little message pops up, and then when it's done, they'll actually see the list. That's great. Again, super simple implementation of it, but I mean, obviously something could go wrong because we all know APIs, 50% of the time they seem to fail. So we need to make sure that we catch errors, right? And even more so, we probably want to have a specific error message that pops up. So we have to do a little bit more work for that. And let's add in some sort of error tracking and error display in our components. So let's say we want to track our errors. Now, oops, at this point, at least in my opinion, this is sort of where we're getting, where the waters are getting a little bit muddy, because the users are just data, but loading is more of a state that you're in the component, and your error message is also sort of data, right? So you're now tracking things in your component that are, some of them are related, some of them are not so much, but you're still just using refs for everything. And with Booleans to track stuff, it becomes a little bit, I mean, this is a simple component, but if you have a more complex component, you can see that, you know, this might not be super nice to work with. And we'll get to that in a little bit, why that is. So let's store, if we get an error back, let's store that value, and let's display it. but we have to make sure that this actually fails at some time. So what we can do is we can just basically randomize the result. So if you say math random, no, so 50% of the time this will resolve, and otherwise we'll just reject. So this fakes an API failure, and we say, oh no, something goes wrong. So if that goes wrong, we'll store that on our error value. And then obviously we have to display it. So let's do that. I'm just going to use EM because I've pre-styled this. So if there is an error, let's show an error message. Okay, cool. So let's see if that works. I don't think it does. Oh no, we'll see. I made a mistake and now I have to debug it. This is the worst. Okay. Let's see. Catch. That should theoretically work. Okay, let's debug this. Reject is not defined. Well, that's because I'm terrible at spelling. There you go. That should be better. Okay, cool. So now, whenever our promise rejects, API call went wrong, whatever, we display an error message. Whenever it resolves, we get our list of users back. Cool. Okay. Just to reiterate, we've now added yet another variable, and that variable tracks if there's an error message. And we already had one for loading that tracks the loading, and then we have our users, which is just normal data. So those are three. Two of them are similar, like loading and error, in my opinion, and then users is just pure data. They all live in the same area, and what's kind of annoying, at least in my opinion, is that you have to set all these things manually, right? So if I, for example, would have forgotten to set that finally state where the loading value was set to false, it would always show a loading message, even though my data was already there. Now, you could argue, and it's a good argument, that you should test for this, and you can do TDD to prevent this kind of stuff, and I fully agree with that. However, it would be really nice if you just would not have to worry about it at all, because this is all manual work, and hopefully when we will rewrite this component in a couple of minutes from now and use state machines, it suddenly becomes clear that you don't actually have to track any of this, at least not in the manual way like this. And states are or aren't available basically, and I think you will find that it's much easier to work with. So let's see. We have our data, but if we want to refetch our data when an error happens, for example, it would be nice if our users could do that, right? There's an error, so let's give them a method to refetch the data. Let me first add a button for that. And we only want to display the button if there's an error. And then we call it refetch. And on click, we want to call fetch users again, so that we refetch our data. So let's also export fetch users here, so that our template can actually call it. So we only want that when we're in the error state, but we also want the error to be gone while we're refetching data, right? Because we don't want to click refetch and then have that error message displayed while we're loading. So what we do is we set, we can do it in two ways. We can set it here, like error.value is an empty string so that it doesn't show up, and then we'll be populated again when we hit an error. But again, you're tracking this manually. You have to set this manually. If you forget it, if you forget to do it, you have that error message show up. And these things create like edge cases. And for me, at least, it adds sort of mental load that you have to think about all these things and keep track of them. And this is a super simple component, and it's already kind of, kind of annoying. So you can see here, if there's an error, we can refetch. It shows the loading message. I hope it ever resolves. Doesn't look like it. Did I do something wrong again? Probably. Let's figure this out. It should theoretically work. Oh, there we go. I was just having a streak of bad luck. I always start doubting myself in these situations. So this works fine. There's nothing wrong with this. And I think, in all honesty, I've written components like this a gazillion times. I think most developers will write stuff this way, also because they're used to it and they'll think about all the edge case and stuff like that. But it's still, you know, you're still doing a lot of things manually. So let's see if we can think about a state machine that would alleviate some of this. I'll show you how to build the machine, and I'll show you how to implement it in our component. And then hopefully when we have this in our minds, like in our, like as a mental image, and we see the end result with the state machine, hopefully you'll think, holy moly, that's so much more elegant to write it this way. At least because that's my goal, right? So let's dive in and do that. So before I write any code, I want to think about the state machine, and that's a bit of a mental shift you have to make when you use state machines. Is that you start out by thinking about all the different states your component can be in, and I find, practically speaking, that this requires some close communication with, for example, a designer, if that's not you yourself, to really think about all the different states a component can be in and think how that user experience should be, because that will dictate the way you write your state machine. In this case, because it's a fairly simple example with a couple of edge cases, basically, I think it makes sense to have 4 different states. So we'll have the idle state that the component starts in, nothing happens yet. We have a loading state where it's fetching data, and then we have a success state when the data was successful, and an error state when something went wrong. So very much like my promise example from the start. To me, it makes sense to have 4 of those states, and you'll find that if you do anything with sort of data handling, these are, generally speaking, states you will probably always have. So that's why I like this example as well. Now, the next step, so we now know our 4 states that we can be in. So let's think about our events a little bit. And thinking back, an event is basically what moves the state machine from one state to the next or to another. It doesn't even have to be the next state. In our case, we're fetching data, so I would say a fetch event would make perfect sense. But there's one other thing that I think is useful in this case. We currently, when we are refetching the data, as in we're retrying to fetch the data when something went wrong, we're still using the same method, right? We still call fetch users. But in state machines, I like to be explicit about different events, and I'll tell you in a second why. So I think the fetch event should happen when you're in the idle state, but a retry event should happen when you're in the error state. And you can name them the same. That's perfectly fine. There's nothing wrong with that. But you'll find that maybe you send off a fetch event from the error state. For some reason, you're in the idle state and you're not tracking that correctly, and something happens and you're like, hold on, this is not supposed to happen. I like to be explicit about those, because if I send a retry event while I'm in an idle state and my idle state is not configured to use that event, then it just won't do anything. And if I send off an event and nothing happens, I'm fairly confident that I configured it wrong, or that I'm in a state that I didn't expect to be in. So that's why I like to be very explicit about them, but you can definitely use the same event name over and over. So let's write our actual machine for this. There's a couple of different things we need, but let's first just configure the actual machine. So I'm just going to call this fetch machine to make it easy. And this is actually using the machine import from the XState library. So let's import that from XState. And this will let us define a machine with a configuration object. And there's a couple of different things that you normally want in this object. The first one is the ID, and that just makes it easy to identify the machine, but you can also communicate between machines, and then IDs become important. We won't be using it, but it's also always nice to have. Then it needs to know what state it has to start in. So if you have our 4 states, idle, loading, success, and error, we want to start in the idle state because nothing happened yet. Then we have another piece that's called context, and I will get back to that in a little bit. You can probably already guess what that does. And then we have our actual states, and this is where you define those different states. So let's for now start with these 4: idle, loading, oops, success, and error. Okay. A little bit about the context property. The context is basically sort of a local data storage for your machine. So in our case, once we fetch our data, we want to assign that value to our user's value, right? And you can still do that in your component if you like, but I always like to do it in the state machine because the two things are related. If I ask the state machine to get some data, I want it to also be stored on the state machine because that keeps everything nice in one place. So that's really what context does. It's really just variables that you can access on your state machine. And then with the event, so if you want to go from the idle state to loading, we know we need an event for that to happen. And you define that in the following way. You use on, and then you can have an identifier, like in our case, fetch, and then you specify where you want to go when that event happens. So literally speaking, this means if I'm in the idle state and I receive a fetch event, go to the loading state. Which also means that if I'm in the loading state and I receive a fetch event, nothing happens because the loading state is not configured to do anything with events at this point. So it's very, very readable. And for the error state, we said we want to have a retry event. And we also want to end up in the loading state, right? Because we want to retry and fetch our data. Again, you could call this fetch, and that's perfectly fine. But in my opinion, if you have the same event in multiple states being handled, it can become harder to reason about why things work or not work, especially when you start logging stuff. I always like to be verbose about this. So this means if I send a retry event, only the error state will handle that. So if I'm in any of the other states and I'll send a retry event, it just won't do anything. So that's what the events do. Okay. So that's a little bit about how the events work in the machine. Now, this only configures the machine, right? It doesn't do anything just yet. It just, makes populates the machine and it's ready to go, but it doesn't do anything. So the first thing we want to do is move our logic that fetched all the data into the machine. And machines have this cool function or this cool property called services where you basically can call things like async functions, API calls. You can even call other machines with it. They basically interact or serve as your it's not really actions, but basically your data fetching and stuff like that. So in order to use a service, you actually use the invoke property. So this means that if I go to the loading state, I'll invoke something when I enter it automatically. And you give it a source, and that's the name of the function you want to call. And then there's two other things, on done and on error. And because anything that's invoked with a service is a promise, it will, when it resolves, you can do something, and when it rejects, you can do something. And these two things just point to a state. So in our case, when we're done, we want to go into the success state. It's basically the same as doing a fetch event, and you say where it has to go. And on error, we obviously want to go to the error state. And this fetch source is actually defined in a services property. Oops, there we go, services, and that's an object. And this is the name that we're referring to here. And then this is what we're going to do with it. In our case, we just want to call the API because that actually fetches our data. And when it resolves, it will go to success. And when it rejects, it goes to error. So that will handle the actual data fetching. But as I said before, once we fetch our data, we want to do something with it, right? And we already have this user array on our context. We want to populate that with the result of our fetch. So the way to do that is to use an action, and it also uses this function called assign. So let me show you how you do that. Instead of directly going to the success state, we're actually going to fire off an action, and then we go to the success state. And the action we're firing can have any name. I'm just going to call it set users because it's nice and clear what it does. And then actions are also defined in a similar way as services. It's going this way. And this is the name of the action you're calling. So set users here, set users here. And then there's this assign function that can basically manipulate the context of the state machine. And it takes the context and the event is actually the data that gets sent back from the promise. And that's how all events in state machines work. They always have a data property where optionally data can live. So in our case, we want to set users. So this refers to the key on our context. That's this one. We want to set users to event.data because that's where our data lives. And this is actually a self-evoking function. There we go. So what we've done here is we say, if we go into loading, invoke the fetch function, which in turn calls the API. And when that resolves successfully, call the set users action, which sets data on the context, and then go to the success state. So when that whole trip happens, you end up in the success state, and now you have users on your context. You can already see like how we're going to leverage that in our component, obviously. So that's what happens. Now, the next step, obviously, is the error handling, because it could go wrong. And we can do pretty much the exact same thing as we do with users with our error. Now, remember how our error was just a ref, like a variable that we stored on our component? We're also going to store it in the machine here. And then it becomes more and more clear what is actually data and what is actually state, and how it's nice to not have to worry about it when you use a state machine. So let's add an error here, and we do the exact same thing for on error. We also fire off an action, and we also want to end up in a target, right, in the error. So here, we're going to call an action called set error. And set error is going to be pretty much the same as set users, except it will set an error, not surprisingly. There we go. So we'll set the error to whatever comes back from the data. And in our case, we rejected with the string, oh no, and that will get set on the error property of the context. All right, so that's you know, it's not super difficult. It's a little bit of setup work, but the nice thing is it kind of makes you very aware of all the different states in your component, where data lives, what actions you have to take. It really makes you think about your component from a more, I don't even know how to say that, more structural point of view, I guess. So now that we have our machine, let's start actually using it in our component, and we'll remove the old stuff so that the component still functions exactly the same way, but now it hopefully will look a little bit different. So let's do that, and we do that by importing the plugin from XState view, and they have this composition function called use machine, and we're just gonna go in here, and I'm actually going to remove everything from our component because we're just going to rewrite it, hopefully fairly quickly. Famous last words, I guess. So we're going to remove all of this, and let's just start over. And we start with actually calling that use machine composition function. So we do use machine, and we feed in, oh, that's the wrong one, our fetch machine. Why can't I type? There we go. Fetch machine. And as I said before, it returns three things. We're only going to use two in this case, the state and the send function. And as I said before, the state is the state that the whole machine is in its entirety. And the send function we use to actually send events to the state machine. And we want to have access to that in our template. So we're just going to return it. Now, I'm going to make it fairly easy, and you can optimize this a little bit later, and I'll talk about that. The first thing we want to do is to get the users. We no longer have this users variable that comes back from our setup function over here, but we have access to the state. And this, as I said, the state is the whole state machine, so our context in the state machine is also accessible. So let me collapse all of this because it's just noise at this point. So we have a little bit of a better view. So in order to get to that, you go to the state, and then you just access context.users. That's all it is. That's exactly the same as having that users variable in your component, but now you're accessing it directly from the state machine. And I hear you thinking, why don't you just use a computed and return that? And that's, I 100% agree. You should probably do that so that you have a computed value that responds when your state machine changes. I'm just going to, for brevity, just going to put it in like this, but that's definitely the way I normally do it. So now we get our users from the state machine and we'll loop through them. Everything stays the same. So that's for the normal data. The same goes for the error, right? We also can get that from the context, and we can do it the same way as we do users. Now, here's where, in my opinion, state machines are really, really good. We're not going to check if error is set. We're not going to do a sort of a string check or whatever. Now we're going to actually leverage the state machine itself. So we don't want to check if there's an error. We want to know if we're in the error state, which is quite a significant difference, but practically the same in our case. And the way you do that is there's a super nice function called matches, and it takes a string and it checks against one of your states and sees if you're in that state currently, or your machine is in that state, I should say. And the nice thing is if you have nested states, so for example, you have, I don't know, loading, and then there's nested states like users and companies and stuff like that. You can have different loading states. You can drill down by using just a period, just like how you would access an object. So you can, for example, specifically check if you're loading users or if you're loading anything at all. In this case, we only have error state and there's no nested state, but that's the way you do it. So we check against the actual state, and the same goes for the loading state. So we will check if the machine is actually in that state, and then we'll display the loading message. And we'll use the same one for the refetch button, and we'll have to do something with the click. But now all our data and our states are wired up to the state machine. And you can see that these three things up here are all dependent on the state it's in. And this one down here is dependent on the data that we have. Sure, technically we could still only display this if we're in the success state. That's perfectly fine too. Might even be better, in all honesty, but that's kind of besides the point. Now, when we want to refetch users, we can no longer just call that function, right? Because now we have a state machine that handles that for us. And we said if we were in the error state and we send a retry event, then it will fetch users for us. So we can do that simply by sending something, and that something is going to be the event you want the state machine to react to. And I think this is just shorthand for an object with a type property. I normally use this notation just because when you send data along, for example, you need to use this, so it's more consistent, but you can totally get away with just doing retry here, and it will do it for you. So now our component is wired up to our state machine, but we haven't actually done anything in the component itself yet. So the state machine will start in the idle state, but we need to tell it to go and do something, right? So the only thing we do here is send fetch, because we were in the idle state. Let me open it up again. And when the fetch event occurs, then it will start loading. And it's so nice because you don't have to do anything. You just send one event off and your component starts loading. And you can do this at any given time, right? You can also not do it and have a button in your interface that does it when people click on it. So it becomes very concise. So I think we've wired everything up, and I'm ready for failure. So we'll see if this works. Wow, look at that. It actually worked. Let's see if we can get, oh, there's an error state with the refetch button. Let's see if that works. Yep, seems good. Let's see if it, there we go. So if we ignore these fake things over here, this now has become your component. There's no manual tracking of data. There's no manual tracking of states, as I would call it, like loading. That's all handled in the machine. And you could argue, hey, now you've just moved all your logic to an external file or an external declaration, whatever. That's partially correct, but there's a couple of advantages, at least in my opinion. The first thing is that you're just configuring a machine. You're not actually programming it and keeping track of things. You're just configuring the machine to behave a certain way, and it will just do that, right? Sure, you have to make sure that you call the right services and actions and stuff like that. But if your error message doesn't appear, you know that you haven't stored it. So there's just very sort of strict ways of doing things, and it takes away all of the sort of the manual thought process about how to track stuff. And a couple of really big advantages I find in how the component is written from a template perspective is that every single thing in our component is a pure expression of the state our machine is in. If our machine is in the error state, our UI will reflect things in that state, basically. And in my opinion, it's such a nice way to write your components because you only have to check in what state you are and what data you want to use in that state, and that's it. There's no more hard logic to think about. Obviously, this is a relatively simple component, and the more complicated your components become, the more work you have to do, of course, and your state machines can become quite complicated, especially when they start interacting with one another or stuff like that. But in essence, even when I write a fairly complicated component, this is still the way that I do it, and it's still the same mental load. It's just more work. So I really like that. Another thing I really like about it is that there are no real edge cases, right? There's no edge case where you forgot to reset the error message, but you're also fetching data at the same time. Those things are not related because you're now in a different state and you're not displaying that thing when you're in that state. You don't have to manually reset it or something like that. So that takes a lot of work away. Plus, it makes your component more predictable. So for me, that's a definite win-win. And another thing is that all the actual logic of the component lives in the state machine, and your component itself is just an expression of that. So you move all the logic over to writing that in the state machine. Side note: state machines are extremely easy to test, very well suited for doing TDD or something like that. So you can literally write your whole test file first, build your state machine against that, and then implement the states in your component, and it will work. So it's, for me, I find it a delight to work with. So just to quickly recap, because we're getting near the end here. First thing, we have moved all our logic into the state machine. The second part is our component is now purely an expression of the machine itself. And third one, and very important for me at least, is you cannot end up in this weird edge case because you forgot to reset or track something. It's purely the way you configure that state machine is the way it's going to be displayed. Obviously, you have to write the implementation of how you want to display stuff, and that there's always room for error there, obviously, but it will be based on the state you're in. And then the last thing I want to point out that I've mentioned before is that just be very mindful of the different events you specify, because if you fire off an event and the current state you're in is not wired up to do anything with it, it will just do nothing, right? There's no error message. It will just not respond. So at the start, when you start working with state machines, that might feel a little unnatural because you're expecting the state machine to say like, hey, I don't know what to do with this, but it probably won't. Actually, yesterday I noticed that there might be a warning when you do that. I think they changed that in one of the recent versions. So don't pin me on that, but it might actually warn you when you send off an event and nothing happens. So that's really it. For me, we use state machines in pretty much all our components, especially when they're heavy UI components. When I saw David's talk, David Corshi that wrote the XState library, I just had that epiphany moment. I'm like, this makes so much sense. Why aren't we doing this all the time? So hopefully I've at least piqued your interest a little bit about what state machines are. I will send some links on the documentation because they have a very, very nice visualizer where you can write your state machine and it will show you in sort of a chart form with like connecting lines and events how your state machine works. And you can actually click on an event and it will move to the next state. It's brilliant. It really visualizes how your state machine is working, and can also help you develop your UI, right? Because it will show you what states you go through. So yeah, that's really all I have to say about this subject at this point. And I just want to welcome everybody to fire off questions. I'm not an expert on state machines, really not, but I gladly will answer any question you have to the best of my capabilities. And hopefully you found it interesting.
All right. Thank you, Reinier. That was amazing.
Yeah, that was really good. I like it. I mean, it feels really declarative, and declaratives are always easier to read, right? I think, right? So,
I mean, a lot of us here are Vue developers, so it would kind of make sense. We appreciate the simplicity, right, of that API. Yeah. I mean, Reinier, do you want to actually show people that visualization? Because I think that's
it's pretty cool. I was looking at it.
I was going to say that, like, I think that was a big click moment for me when David presented it, because it's one thing to see just an object, but anyways, I'm not going to spoil it. Let's let
let me. All right, so this is. Let me make this a little bit smaller. I think this is oh, this is a simple fetch machine.
Yeah.
So
can you zoom in at all on the chart?
Yeah, I think so.
Perfect. Yep, I thought it was SVG. Yeah.
Okay. Yeah, there we go. So this is fairly similar to what we just did. This is, I think, a promise model as a state machine. So this is your entry state, the idle state, and then the idle state only reacts to a fetch event, right? Now we can read that here. Idle reacts to fetch and will go to loading. So you click that, now you're in the loading state. And in this case, they modeled it manually. So from loading, you send an event that will then say resolve or reject. Normally this would be an async thing. But like you go to reject, now it's in the failure state. And now you have access to this retry event and they actually keep track of how many retries you do. I see here in the context. So if you hit that, you go back to loading. And this is like, it's hilarious because once you start writing more complicated state machines, this thing goes absolutely wild. Like you have all kinds of things and charts, but it's so nice to be able to step through all the different things. And I found it especially helpful for things like forms where you want to do validation and stuff like that, right? And you want to see, oh, if this goes wrong, can I actually submit it or not? Like, no, you can't because you're in the wrong state. And it just clicks, at least for me.
I just did this really complicated form, and when you were doing this, I was like, "Where was this?" When I did my complicated form, because it's like, yeah, it was a struggle to make it really readable, which is why like this I find very easy to read, and it was really a struggle to make that form readable.
Yeah, no, so it's, and like to give a practical example of the work that we do, in our app, we have an absolute ton of async data loading in. So we use this whole pattern of like fetching data and stuff like that, pretty much all over the place. And we use graph for all our queries and mutations. So even if you fire off a mutation, you can go to a loading state, and that loading, when you enter the loading state, it will actually do the mutation for you. And once that resolves, you go to the success state or to the fail state. And all of a sudden, when you build things like dashboards or whatever, all these things come together and they just work as little entities. And for me, it was, yeah, like I said, like an epiphany when I saw this. I'm like, this makes so much more sense. And I love that there's a visual way of seeing it as well, because I'm a very visually oriented person. And when I read through docs, it's like, if there's text, I'm kind of lost. I just can't. When there's an example, I'm like, okay, now I get it, right? So and everybody works differently, but for me, this was really helpful. And it just makes writing components a breeze. It really does.
Wow.
So yeah, if there's like, let me open the chat here real quick.
Yeah, please do.
So do you find you're using this pattern? Like, are you just using it for new components? Are you switching over your old stuff to this? Like, how are you all approaching?
Let me give a typical dev answer to that. It depends. So we have.
I thought I'd ask anyway.
We have a couple of different moving parts, and our component library itself does not use it. There's actually only one component, a modal component, that does use it, which is kind of overkill, but mainly because they're just UI utilities, with a bunch of props. But in our app, all our components that then consume those components and build actually, functional things with it, all of them use it, every single one of them. We have a couple of machines that we reuse, right? Because that's one of the things as well. You can make a fetch machine, and then you can just reuse it in different components. You don't have to rewrite this thing all the time. If you have one of them, you can reuse it. You can even make it a factory function where you have this fetch machine and then you expand on it with different properties and things. So and in the end, it's just JavaScript. I mean, it's all very sort of like reusable, and you can build on it. So yeah, we use it everywhere.
Yeah, we're still unfortunately in Vue 2, but I saw that there was a Vue 2 version of this. So
yeah, there's an XState library for Vue 2.
Yeah, that's what we started with until we switched to Vue 3. And honestly, it doesn't matter. It's the same end result. So yeah, I would definitely encourage you to look into it and see if it helps. Yeah.
Does it like create a new object that's state? Because you did this in the composition, like the setup part, right? Isn't that where this was done? So in Vue 2, how is it done in Vue 2?
I have to try to remember.
Like
if you look at the docs right here, I think there's gonna be an example you can show.
Let me see.
Also, could you full screen your browser, because we only see half the window? And I think the Zoom stuff gets hidden, so we don't actually see. I think if you were showing the Zoom stuff, we don't. Zoom stuff. Okay. So it's in tutorials, I believe.
Okay, I thought it was.
Oh, that would work too. I think.
That's the.
Oh no, that's the GitHub. Yeah,
so
so on the left-hand side, usage with Vue. Yeah, that should work. No, this is just the package. There we go. This one.
So same thing for declaring it.
Import it.
Oh yeah, they use an interpreter.
The created state. Yeah. So it's analogous to Vue 3's setup in that regard. Like when the component is created, kick off this.
Yes. Yeah.
And then. Yeah.
Oh, it's all like in the data. Okay.
Yeah. So this is taken care of in Vue 3. This is all done in the composable.
Yeah, right? Actually, it looks nicer in Vue 3.
Oh yeah, for sure. Like it's literally one line and you destructure
Yeah.
it, you get back and that's it. But I think current is the same as state in view 3.
Right.
And then like the nice thing here is you can return whatever you want. So the context not even that useful probably. You can just return the machine if you want. But yeah, it's a little bit more setup work for view 2.
Right.
It's been a while since I've done it, to be honest, but
Right.
it functions the same way. So, yeah.
This is the kind of thing that makes me like, I was sort of skeptical with the composition API, but these are the things that make me think, oh, the composition API is worth it. So yeah.
We spent all that time for a reason, Tracy.
I know.
There's a reason for it.
Yeah, I just, it was just so different, just like that's really what it was about. It was just so different. I wasn't used to it. I mean, that's really what it was about.
Yeah. We were lucky in our project that, so I built the first version, I believe on view 2. And then I was lucky enough to start over. I'm like, oh, let's just go all in, we do view 3, we use Vite for
nice.
For the bundling, everything TypeScript.
Yeah, I saw the Vite. I saw you had Vite. Yep.
Okay, yeah. It's a lot of
fast.
It's a lot of work at the start, but then once it runs, you're like, I'm so happy I did this.
So we do have a question.
Yeah,
it's from Bill. Tracy, you want to go for
it? Yeah, it says, can you describe a simple case of nested states and how the architecture of your example would change as a result?
That's a great question. Do I have a simple case of a nested state? Yeah, like I think I mentioned it during the talk that especially when it comes to like loading states or something like that, I occasionally have components where there's multiple things that can load and they're not dependent on each other. So for example, our order system loads orders and assignments simultaneously. So I would shape that in like a loading state that has then an order substate and an assignments substate. And then I have 2 events, one called fetch orders and one called fetch assignments. And depending on those events, I would go to either one of those substates. And that also means if you shape it as a parallel state, that even though I said a state machine can't be in 2 states at the same time, with parallel states you can be in 2 states at the same time. Then you could leverage the loading state in general to show like a full screen loader if you wanted to, or you could drill down into loading orders or loading assignments for just that specific part of the component, for example. Let me see if I can show you how that would look. So in this case, maybe loading is not the best example in my talks code, but let's say this doesn't actually invoke anything. You would literally do something like this. In our case, like users and I don't know, orders or something like that. And then in here, you could still do something like invoke and then call your service, right? And that allows you, the only thing that you have to change is you have to specify the type to be parallel so that the state machine knows that users and orders can be in those 2 states at the same time, which is a state chart capability. I'd have to look it up because I very, very rarely use parallel states, mainly because I try to keep my components very, very small and concise and do one thing. It's kind of, I read this thing about Linux a while ago or Unix, I believe, where they force you to write applications to do only one thing and do it really well. And I kind of like that idea because it really narrows down your scope, right? And sort of like takes away the edge cases. But I think you would do something like type parallel or something. And then it allows you to have multiple substates. I'd have to look it up. We can actually look it up if we want to. Parallel state nodes. Here we go. Let me get rid of this. Sorry. So this is the normal way of declaring it, I believe. Okay, yeah. So here you have. Let's see. The upload state has an idle state, and a pending state, and a success state, and then the download state. So these are 2 parallel states. Upload and download are parallel states. So for example, I think this component will be something where you can upload data, but also at the same time download something. And by declaring them as parallel, they basically become, it's not so much it can be in two states at the same time, they just become sort of separate pieces of the state machine that can react at the same time. And the visual of that is like this. So you get like a nice outline where you could hit this one and then this one independently, right? Like they don't influence each other. They live side by side, but they're still part of the same state machine. And in this case, they're just part of the same substate as well, or parent state, I should say. So that's basically how you shape it. It's really just adding a keyword, and now you have access to two states. You'd have to look through the docs a little bit to see what a really good use case would be. As I said, like I rarely have ever used it, just because I don't really get into those kind of situations, I guess. But I'm assuming they can leverage a lot of things. And the only thing I do get into it with is with the forms. So what I normally do is I track if a form input has an error or not. So you literally have like substates called error or no error for like the email address, but then a parallel state will be the password. And then while you're typing, you could send events to the email substate, and then when you're typing your password, you send events to the password substate, and they live independently, but they still live in the same machine, right? Because otherwise, you could only ever track one thing, like only the email or only the password as it comes to the state. And if your email is in an error state, you now have to say like, oh, but if I'm in an email error state, now I have to have a substate for my password that can also be, it becomes very hard to manage. So that's why they have those parallel states. And that's where I mainly use them for forms. Yeah, so it's really just adding a type, and then you basically have two states to work with. And this like a traffic light example, I believe. Okay, got it. Yeah, you'd have to read through it to see if it makes any sort of sense in your use case. Again, I don't use them that often, but for forms, they're great. Yeah. All right. I hope that answered it, by the way. It's a bit long-winded.
That's great. Yeah, Bill, if you have any clarifying questions. Okay, perfect. Oh, I see Brian coming in. So how does XState fit in with Vuex?
Ooh, wow. So confession time. I don't use Vuex at all. And that's kind of funny because I used to use Vuex every day until I moved to this project, basically. So short answer, you can use Vuex and state machines together and have Vuex still manage like global states and state machines more sort of as a local way of doing it. We're in the platform that we build, which is quite a big platform. I actually use two state machines as global state managers. So we only need to track a user, so basically an authenticated state, and then the current business that they're in. That's sort of how our routes are based. They're on the route levels on the business. And we track things like statistics on the business, and that kind of like, and it has the business ID and that kind of stuff in it. And the nice thing is it's just an ESM module, an ES module that has a state machine in it. It runs when the application starts, and then I just import it everywhere where I need it as a it's actually as a composition function. So I just have a function called use business, and then a couple of properties that I can destructure. And that's really just a state machine where I store data on the context that I now have available globally. People will probably crucify me for doing that, but it's I think Vuex or Vuex is super helpful. But the thing I do not like about it is that it tracks data and states. It treats them as if they're the same thing, right? You still use Booleans for if stuff is loading or not, and you still have your arrays and objects and strings to store data. You're still fully responsible to write the correct actions and mutations to set or reset certain parts of XState, and it's great for sharing data across your app through different components that are not necessarily connected to each other normally. But I still find that from a declarative point of view, from a logic point of view, that it's lacking a bit. So it's great as a data manager. Mm-hmm. I don't like it that much as a state manager, so to speak. I've contemplated the idea of writing XState, which would be an XState driven Vuex implementation, whatever. I just don't have the time for it. But that I don't know, maybe someone would like to check that if that's a possibility. But that's my view. That's my view on Vuex. Not to discredit in any way, because I absolutely love it as a data manager. But from a pure state point, I have my reservations about it. Let's put it that way. Yeah.
Great answer.
Yep. Yeah, I'm not a big fan of Vuex either.
It's gonna get better. We're working on it.
Oh, really? Okay.
Yeah, Vuex 5 should be coming with some DX improvements.
Cool.
Okay.
All right. Yeah, if there's
Tyler here has I guess this is just a comment, but have you used Overmind? Apparently he says that this has also finite state machines built in based on XState but stripped down. So I guess if you're ever looking to play around with something, check out Overmind. Recommendation from Tyler.
Interesting. I got a StarCraft wiki.
StarCraft. Oh man, that brings back memories.
Wow.
Overmind JS is what Tyler.
Of course, it's Overmind JS.
Oh god, now I want to make like Zergling JS and like Hydrolis JS. Like,
build additional pylons.
That is great.
I will say that XState is pretty elaborate. Like I've not even scratched the surface of what it can do, and I find I use a very small subset of it mainly. And on the Discord they do some incredibly insane stuff with it. So I could see that maybe there's tools maybe like Overmind where it's a little bit more condensed and stripped down more to be a little bit more functional for writing components with. You can still do it with XState, like there's nothing wrong with it. But it's fun to see that more people are picking up on this, or more libraries are trying to do this, which is nice. Yeah, cool. It's somewhat similar.
Great.
All right.
Well, I mean, with that, does anyone have any other questions? I give you all like 30 seconds in case there's like a lag, but gosh, in the meantime, Reinier, this was awesome. Thanks so much for this amazing talk.
Yeah, cool. Thanks so much.
Oh, thanks for having me. Love doing it.
Love in the comment. Oh, do you have time for a Vuetify CSS question? Would you, or I asked it on the Vue DC discussion board. Okay, so this might be separate. So
it's probably for you, Ben.
Yeah, this one might be for me.
You're the Vuetify expert. I hand roll everything.
Hey, I like writing CSS as well.
Well, but I write our libraries. I'm responsible for the component libraries. So that's
fair enough.
I'm supposed to hand roll everything.
But okay, at the bare minimum.
Although I have to say something real quick before you answer the question.
Please.
I brought in Jack's Vue multi-select thingy, whatever.
Oh, you did?
Yes.
Oh, wow, I'm very surprised.
I know. I really like it. They did a great job. Anyway, okay. Carry on. Tell Jack.
Cool. I mean, Reinier, are you good on time? I don't want to keep you if you're if you want to hang out for Q&A a little bit. And okay, we'll just stay a bit longer. And then so Wendell, what is your question regarding Vuetify CSS?
Do you want to give him voice if he's okay.
Oh yeah. Oh, I totally forgot that. If anyone wants to speak, you're more than welcome to. We just have to manually toggle on the voice. So feel free to raise your hand if you want to speak, and then otherwise we'll keep an eye on the chat. But yeah, that may be that was probably the talk I needed to finally also start building with it myself. So maybe I'll try to do it on a live stream sometime to play with it, because I do think you're right. I think state is one of those things that's tricky. Like it seems like, oh, it's fine, I'll just set these things and then I'll cover the edge cases. But over time, it's a bit like Vue, right? It's like I could manually render these things, but like at what point you're like, I don't want to solve the same problem over and over again. Like something else, please take care of it for me.
Right.
And let me go on to something else.
Yeah, I agree. I just find it like it's one of those tools that's out there that could make your life easier. Not saying that it should, like it's, there's also a little bit of investment time, right? You have to learn this new thing, and that's always sort of like, I don't know, that brings a little bit of load on you. But at least in my experience, when I started working with it, I went through this, I'd say maybe a short week where I was like kind of frustrated and sort of searching for how stuff works. But once I got the hang of it, I'm like, wow, yeah. So.
Now I'm trying to figure out how to redo my form. Just delivered it. I got to get the product owner to agree to let you do it.
Def life. Spent 2 weeks building something, and it's like, okay, now I'm ready to start it.
Well, it's like the drop downs and stuff, which is why I use the Politico view select thing. Don't tell Bloomberg. It's like all these the fields are actually coming from APIs, a drop down. So that's why this would have been really like awesome to use, because we're pulling all these different APIs. So
nice. Wendell, I checked the VUDC Discord channel. I assume that's what you're talking about, but when you said discussion board, maybe it's somewhere else that I'm not aware of. Brian.
I actually don't speak any French, so I speak Dutch at home with my daughter and my wife, but yeah, no French. No
French. oh gosh.
Okay.
How did I miss this? I don't know how I missed this feature on Meetup. Apparently we have a discussion board on meetup.com. My apologies. This is great. Okay. So I guess, you know what? I'm gonna just share screen and let's
you know what? I didn't realize we had it either.
I don't know. I didn't get like 0 notifications for this.
Yeah, either said it with me.
So yeah, so if people didn't know, we have a discussion board here on Meetup, and thanks to Wendell, we will now be keeping a much closer watch on this. It's weird. I got like, there are some notifications, but like
200 discussions since 2017.
Yeah, holy smokes. Anyways, I wonder if it's like an amalgamation of things. Anyways, funny. All right, we will definitely keep a better track of this. But anyhow, so all right, so here we're talking about vdata table to be compact. TD type doesn't want to be used. So I mean, all right, so this here, I mean, taking a look at this at the bare minimum, we see here that, let's see, padding 0. I mean, something is, oh, I think I already have a hint on what this is. I think the width is already 100%. Yeah. So a key, oh man, hold up.
Does he have a siren going by or something?
Yeah, it's honestly, it's like one of the downsides of where I live. Unfortunately, since I do a lot of recording and streaming and this kind of stuff, it's just like sometimes, I mean, it's never a good time, right? Just like, brah, it's just like, anyways. So yeah, so Wendell, so basically the width here, compactness is not because of any sort of padding. So the reason why I knew that almost kind of immediately is because when you hover over these, you can see that like the blue that represents the width basically, and then the padding is your green. That's how I know that something else is basically most likely calculating it. And so based on that alone, I would, and based on some experience, I knew that the table was most likely being defined. So we can see here, you can inspect the selector to kind of kick it down. And if you want it even more condensed than that, then that's where I'd maybe come in and disable, like, oh, I can already see there's some inline stuff, but like I see a min width being disabled. And then is there a padding somewhere? There's gotta be a padding somewhere. Oh, here's padding. There you go. So that's even more condensed, but I think this is now a little bit too close. But I think hopefully that gives you just enough of a hint of what you want to start to override. So yeah, Hope that was helpful. All right, let's see. Was that cool? Great. In that case, I'm going to do a quick gloss over. Oh my gosh, some of these are from like last year.
I had no idea we had that.
So bad. Yeah, we're very active on Discord though. In our defense, that's what we half expect the questions to be. So we definitely that allows for a little bit more of an interactive bit. So what's nice about Discord as well for those who are new, even though it might feel like another chat service, is that it does a really good job archiving the chats and questions, whereas like Slack has like a limitation past a certain point. So that's why Discord, I think, is a really people really love it for like, especially for communities, so that you don't have that sort of paywall in the end. So, oh yeah, I totally need to look through this later. All right, great. With that, once again, a huge thanks to Reinier for coming out. This has been an absolute pleasure. So yeah, I mean, honestly, if you ever be up for it, maybe we can like collaborate to do like an XState workshop, just to have people like just play around with some hands-on stuff. I think people would. This is a great concept. So cool. I guess as a final reminder for those who are looking for Reinier on the Internet of Things, he's the Dutch coder on, I think you're on all the things, right? Like Twitter, GitHub, Discord, and Discord as well. So yeah, that's where you can find him. So once again, thanks Reinier for coming out. It's been an absolute pleasure.
Thanks so much for having me, and well, hope to see you guys soon again.
Yeah, sounds great. Well, thanks everyone for coming. And then next month, September, I believe we have a chat about some from some developers who have experience coming from React to Vue, talking about some of their perspectives, and we're doing some live Q&A as well. So we'll get that stuff on meetup.com up as soon as possible. So once we do, check that out for our next meetup. So thanks again, everyone, and we'll see you next month.